Hello class, welcome to another lesson. Today we are going to be working on transformations. So our learning goals are I can determine the difference between and identify similar and congruent images. Okay? We're going to continue working on this learning goal for a little bit through multiple lessons, but we're first going to learn about what the differences between similar and congruent images are. The second one is I can translate an image and determine the rule for translated image. So let's get started. The first thing is we're going to learn quite a few definitions. Okay, geometric transformations. They involve taking a pre-image and transforming it in some way to produce an image. Okay, this is what you guys did with that activity. Okay, so transformations include dilations, slides / translations. Then they also include rotations, which you guys didn't do quite yet, but we'll get to. They also include reflections. Okay, so there's 4 different types of geometric transformations. Now, those fall into 2 different categories. Okay, so rigid transformations are transformations that do not change the the size or the shape of the pre-image. So this includes rotations. Okay. This includes slides or translations, and this also includes reflections. Here, non-rigid transformations, those are the transformations that will change the size but not the shape of the pre-image. Okay? So this would be, for example, dilations, okay? Making something bigger or smaller. Which takes us to what congruent and similar images are. Congruent images are ones that look exactly the same both in shape and size. Okay? If the post image or image could be cut out and placed on top of the pre-image, it would overlap exactly. So that means that rigid transformations produce congruent images because rigid transformations do not change the size or the shape of the pre-image. Similar images are those that look exactly the same in shape but not size. So non-rigid transformations produce similar images, so that it would be dilations. They would look exactly the same, they'd be proportional, the size would be proportional, but they are not the exact same size, so that would be a non-rigid transformation. So here, triangle ABC is congruent to triangle A colon B colon C colon. So, you guys can see that these two A and B, this triangle and this triangle, they are congruent because they look exactly the same. They are slightly rotated off of each other, and that's perfectly fine. What this means right here, this line right here, and this angle, and this angle with this line right here, that means that these two angles are exactly the same. So the angle of A is the same angle as A colon. Same thing with B and B colon, and this hypotenuse right here. This line right here means that this length is the same as that length. They are in fact congruent. So this equal sign with a little squiggly on the top, that means those two are congruent. Here, these two are not congruent. ABC is not congruent to DEF, even though the A and D have the same angles, B and E have the same angles, C and F have the same angles. Their side lengths aren't the same. Okay? So they're considered similar. Okay? Because all I have to do is multiply each one of these sides by 1.5 to get 9, 6, and 4.5. So this squiggly line just means that they are similar. They are not congruent, however. Okay. So that's congruent and similar images. And we're going to start talking about translations and slides. So in a translation or slide, the shape will move to the left or the right and or up or down. The shapes are considered congruent because they maintain the same shape and size, and you can write it using mapping notation, translation notation, or written notation. So for example, if the rule means what do you do to the shape to move it. Okay, so if the rule is you move the shape one spot to the right and down 2, to write that, you first have to consider that left and right is determined by the x coordinate, right? And then up or down is determined by the y coordinate. Okay, so one movement to the right means that we're going to move it like this, one to the right and 2 down would be negative 2, just like how it would be in the coordinate points. X, Y, right is 1, down is negative 2. Then you can also write it with translation notation, so it would look like this. X comma y turns into x plus 1 comma y minus 2, because you're subtracting 2 from the y and adding 1 to the x. The written description is just like what it is up here. You just simply write translate up 1. Ooh, excuse me, not up. That's not supposed to say up. That should say to the right 1. Okay. Let me just fix that real quick. Translate right 1 down 2. Okay. So that's what is called the written description. Okay. So here, the first example, translate the figure below 6 units to the right and 1 unit down. So we have D, C, and E. So we're going to translate D over 1, 2, 3, 4, 5, 6, and then down 1. So D should be right here. C is going to be 1, 2, 3, 4, 5, 6, and down 1. So C is right here. That means that E will be right here. So therefore, it should look something like this. Be sure to label all the points on your image. Okay. So this is the pre-image over here, and this is the image right here. And the new location of C colon is, or excuse me, apostrophe is right here, and that is 1, 2, 3, 1, 3, comma 1. So you have written like this: C parentheses 3, comma 1. So first it says graph the figure that has the vertices G, F, and E. So we have negative 5, negative 4. So that's negative 5, 1, 2, 3, 4, 5, down 4, 1, 2, 3, 4. So G is going to be right here. F is going to be right here, and E is going to be right here. So, or excuse me, right here. So the image should look like this. Excuse me, right here. G, F, E. Okay. What shape is this? This is a triangle. Okay. So let's write that down. Triangle. Triangle. Oh, come on, let me write. Triangle. Okay. That's a triangle. We got points here. And so that is the translation right here. Oh, yep, so translation is up 4, so we move everything up 4. So this is our new image. Are they congruent or similar? Because they have the exact same lengths for each side, they are congruent. Okay. And the location of the F, the new location of vertices F, so that's F apostrophe F. So what that is F parentheses, and that is going to be negative 5, 0. Okay. So here, number 3 says the triangle LKJ, this one right here, was transformed to form the new triangle right here. Write the rule in 3 different forms. So let's start with over here. The rule is to the right 3 and up 1, 2, 3, 4, 5, 6, 7. So that means to the right 3 up 7. So that can be written like the following: 3, comma 7, because that means to the right, and then up. The next way you can write it is as follows: x, comma y, arrow to x plus 3, comma y plus 7. And finally, you can just write in written form, translate up 7 to the right 3. Example 4, go ahead and try this one on your own. be careful with the wording of the question. So we have the figure up to. That means that every y coordinate is going to go up 2. So this 1 becomes a 3. And then to the left 3, that means we're going to subtract 3 from every x coordinate. So this becomes, a becomes negative 3, 3. B therefore becomes negative 1, 7, because we're taking down 3 from 2. And then up 2 to the 5. And then C becomes 3, negative 5. What is the coordinate of the new A? The x-coordinate of the new A is simply 3. Or excuse me, negative 3. Goes to right here. And the rule written in a different form, so let's go with right here the mapping form, which means that we're going to the left 3. So this could be 3, negative 3, excuse me, comma, up 2, like that. Okay? Go ahead and try number 5 on your own. Here we're going from negative 169 to negative 203, which means that there's a change of going to the left by 34. Okay. And then we're going down a whole bunch. That's going down for a total of 502. So left 34, down 502, which means we're going to take this 31, subtract 34, take negative 529, subtract 502, which gets us B apostrophe is negative 3, comma, negative 1031. Go ahead and try the practice. Good luck.